to work on solving midpoint problems today, and we have actually several videos, or several examples we're going to do in this video, specifically 3. And we're going to start with the one given here. B is the midpoint of AC, and we know FE is 2x, the length of EC is x squared, and FB is equal to 24. So when it says B is the midpoint, I'm going to label it. But it doesn't tell me anything about E, and that's fine. But I'm going to do as we did on yesterday's problem, 2x, and this is going to be x squared, and FC is going to equal 24. And it wants to know what is x. So let me write that rest of the question here. What is x? So in reality here, our midpoint doesn't really mean anything to us because all we're talking about is here. We don't know these are equal, so we go back to what we just did. FE plus EC equals FC. 2x plus x squared equals 24. Remember, this is a quadratic. So x squared plus 2x minus 24 equals 0. I'm unable to pull out a GCF, so I'm going to factor this down to x and something x equals 0. And I'm going to go through and it's 6 and 4. So it's positive, so I have a positive 6 and a minus 4. I need to set my roots. So x minus 4 equals 0. X equals 4. X plus 6 equals 0. X equals negative 6. Now, what's important here is that I must check to see if this works. So 4 times 2 is 8. Great. 4 squared is 16. Great. So 4 is a solution. Now plug in the negative 6. 2 times negative 6 is negative 12. You cannot have a negative length. So this now goes away. The only answer I would have is 4. Our next example is going to look like this. We're going to state that PS is equal to 3x plus 2. SQ is equal to 4x minus 5. And PQ equals 39. Is S a midpoint? I guess I need to spell correctly, so excuse me. Is S a midpoint of segment PQ? Now, they would have given us a picture, and our picture ahead of time looks like this. So in this particular case, there's a picture. And I'm going to put S right here, and I'm going to draw a line L through it. Now, if S is a midpoint, that will mean that this line is a bisector. It is not a perpendicular bisector. It is just a bisector. But I don't know it's a midpoint, so I can't set it up that way. So what I'm going to do is, again, start off with what you know. PS is 3x plus 2. SQ is 4x minus 5. PQ is 39. I do not know these equal each other. I'm asking if they do. So I'm going to set it up in the same way I've done everything else. PS plus SQ equals PQ. 3x plus 2 plus 4x minus 5 equals 39. Combining like terms, 7x minus 3 equals 39. 7x equals 42. X equals 6. Now I'm going to plug in. So PS is equal to 3 times 6 plus 2, which is 20. And SQ is going to equal 4 times 6 minus 5. So 24 minus 5 is 19. PS is not equal to S cubed. Therefore, S is not a midpoint. Okay, so that's when we have to see if it's a midpoint. So again, let's remember where we started. I just told you something is a midpoint. We didn't need it. We just did segment addition. I'm asking you if it's a midpoint, so I don't treat it as such. I still do segment addition. My last example is actually doing a midpoint problem. So on my example, I'm going to have M is midpoint of segment AB. AM is equal to x plus 8 over 3, and MB is equal to x minus 1 over 2. All right. Now, I draw my picture, because I don't even know. They didn't give me a picture. The other ones, they would have given them to me. So I'm going to set this up. A, B, M is in the middle. This is a midpoint. They are telling me flat out, this is midpoint. Mark them as congruent. That means that this guy is x plus 8 over 3, and this one is x minus 1 over 2. I cannot have a hole because they equal each other. Okay, it would defeat the purpose. So now I will come down and say x plus 8 over 3 is equal to x minus 1 over 2. That's going to give me 3 times x minus 1 equals 2 times x plus 8. Remember, we just cross-multiplied back from junior high. Cross-multiply. 3x minus 3 equals 2x plus 16. X equals 19. When I plug this in, AM equals 27 over 3, which is 9. And MB is equal to 18 over 2, which is also 9. So I did do the algebra correctly. Good luck on solving midpoint problems.